In this problem, we're asked to determine the total 1 ohm energy content of the output V0 of t if Vi of t is 5 e to the minus 2t u of t. And really what we're going to do is we're going to use Parsifal's theorem here. We'll come up with an expression of V0 over omega and use that. To start off with, we need to convert to a frequency domain circuit. And if we notice, for instance, we'll need to take the Fourier transform of our source. And if we look at the Fourier transform for our source, then Vi of omega is 5 over 2 plus j omega. So now our frequency domain circuit, notice we've taken our inductor and its impedance now is just j omega. So now let's calculate V0 of omega. So by voltage division, we have 10 over 10 plus j omega times 5 over 2 plus j omega. So we have 50 over 10 plus j omega times 2 plus j omega. Now, if you go and look at the magnitudes of these and square it, so for instance, if we went in here and found the magnitude of this and magnitude of that, and we squared all this, the magnitude of V0 of omega squared is 2500, which is 50 squared divided by omega squared plus 100 times omega squared plus 4. Now, in using Parseval's theorem, the energy is 1 over 2 pi integral from minus infinity to plus infinity of the magnitude of V0 of omega squared d omega. Now we're going to take and just integrate over, since the function's symmetric, we're going to just integrate from 0 to infinity. So we'll have 1 over pi integral from 0 to infinity of minus V0 of omega squared d omega. So we now have 1 over pi integral from 0 to infinity of 2500 over omega squared plus 100 times omega squared plus 4. And what we need to do is we need to do a partial fraction expansion of this, and then we'll be able to take the integral. So we take this 2500 over omega squared plus 100 times omega squared plus 4. We can write it as A over omega squared plus 100 plus B over omega squared plus 4. And the way we'll find A, for instance, we'll multiply through by omega squared plus 100 and let omega squared equal minus 100. So A is 2500 over omega squared plus 4, evaluated omega squared equal minus 100. And that's 2500 over minus 100 plus 4, which is 2500 over minus 96. And then for B, we'll multiply through by omega squared plus 4 and let omega squared equal minus 4. So B then is 2500 over omega squared plus 100, evaluated omega squared equal minus 4. And here we'll get 2500 over 96. So now we've completed our partial fraction expansion. And then W is 1 over pi integral from 0 to infinity of, now we'll have 2500 over minus 96 over omega squared plus 100 plus 2500 over 96 over omega squared plus 4. Now, these two terms, we integrate them, are going to be arctangents or inverse tangents. So our terms then become, we have 2500 over pi. We have 1 over minus 1 over 192, inverse tangent of 2 over omega, plus 1 over 960, inverse tangent of 10 over omega, evaluated from 0 to infinity. So we have 2500 over pi minus 1 over 192, inverse tangent of 0. When we plug in omega equal infinity, that's going to be 0. We have 1 over 960, inverse tangent again of 0. Now we have minus 1 over 92, inverse tangent of infinity. When we plug in 0, so now we have 2500 over pi. This term is 0. This term is 0. Okay, we have minus, now minus 1 over 192. This term is pi over 2. And this term is also pi over 2. So now we have 2500 over pi. We factor out a pi over 2, and then we have 1 over 192 minus 1 over 960, and that gives us 5.21 joules.